Class 15 of Power Electronics Chapter 2 for KPT Electrical Diploma students. UJT Relaxation Oscillator. This figure and this figure both are one and the same. The supply voltage VCC is shown in this way. So VCC charges the capacitor via resistance R. VCC charges capacitor via resistance R. Suppose say VCC is around 10 volts and intrinsic standoff ratio of UJT is 6 volts. So this will charge, the capacitor voltage will increase 1, 2, 3, 4 like that till 6 volts plus the breakdown of this PN junction, say 6.7 volts. When the capacitor voltage reaches 6.7 volt, this junction will break down and the capacitor will discharge in this path. So capacitor will charge through R and discharge through R1. Capacitor will discharge through R1 and also through the PN junction. We can see here in the next page, see the charges and discharges. This is the capacitor voltage. So this is the peak point of UJT as we have seen in its characteristics. When the UJT reaches its peak point, means when the capacitor voltage reaches the peak point. Capacitor voltage is nothing but emitter voltage because it is connected to the emitter. So the UJT discharge, the capacitor discharges because UJT conducts. When it discharges, the negative resistance region, as we have already seen in the characteristics, this is the peak point and valley point. This is the same as what we have got here. So it charges through R and discharges through R1 plus RB1, a small resistance RB1, that is the resistance between the PN junction from here to here. So that is also there. So totally we can see here the waveform will be like this: peak point, valley point. We can change this shape. Usually R1 will be small. We will keep it for small value because we will explain later. Because then we will get high slope here. You can adjust. If you keep this R1 large, R large, you can get like this also. Slowly charging. If you keep RB1 or R1 large, it will come like this slowly instead of like this. But usually we need a short pulse for triggering SCR for application of gate signal. So we will keep this small. Since it is small, the slope of the discharging curve will be fast or high. So this is the charging, discharging. This is the total time period. So we can see that the UJT is acting as oscillator itself. If you take the output here across capacitor, you will get like this. If you take output at B1 with or at RB1, okay, here with respect to the ground or negative, you will get waveform like this. So it is working as relaxation oscillator. Relaxation means itself. You are not going to do anything. Itself it is working. It is going to give continuous waveforms.